All right, so now we're going to be working on trigonometric functions of angles, and this is from 6.3 in your books. And we're going to be spending a little bit of time on this, but I wanted to kind of present all the information here. So let's start with your objectives. You will be able to define the trig functions of angles. You will be able to evaluate trig functions at any angle. And you will understand and apply your knowledge of the fundamental identities of trig to evaluate functions. All right, so let's start with the basics. So given the diagram below, let's go through the different trig functions as it applies to the right triangle. So we've got sine, cosine, tangent, all of theta. So this is just for any angle. So I labeled the hypotenuse as r. So of course sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And then we have our reciprocal identities. So basically everything flips. And you also don't forget about these restrictions. So you cannot have, for tangent and secant, x cannot be 0. And for cosecant and cotangent, y cannot be 0. So again, this should be a refresher. You should already know this. All right, so now let's go ahead and work on evaluating trigonometric functions at any angle. Okay, so it's important to remember which functions are positive where. So remember that all students take calculus. So here, all trig functions are positive. Over here you've got sine and its reciprocal function. Over here you have tangent and its reciprocal function. And then you have cosine and its reciprocal function. Do not forget that. Okay, also, make sure you understand reference angles and coterminal angles. It's going to make this a lot easier. So if you need to, you might need to go back and review some of your notes from the previous chapter because all that applies here. Okay, and so if you've done problems in radians before, the only new concept would be completing the problems when you're given a degree measure. Otherwise, it's exactly the same. All right, and just as for degrees, in order to find the reference angle to make your lives easier, I've come up with this. So if the angle is in quadrant 1, and you'll be able to determine that given the degree measure, just whatever the angle or coterminal angle is, if it ends up in quadrant 1, that's your reference angle. For quadrant 2, it's 180 minus the angle, or coterminal angle. In quadrant 3, it's the angle or the coterminal angle minus 180. And then in 4, it's 360 minus the angle or coterminal angle. So let's do some problems, both one in degrees, one in radians. So we've got the sine of 150, which puts us in, so you need to say, well, here's 90, this is 180. So it's in this quadrant, which is quadrant 2. So we know we have to do 180 minus 150, which gives us a reference angle of 30. And we know that sine at 30 degrees, or in radians would be pi over 6, is 1/2, because sine is positive over here. Easy enough. Cosecant of negative 7 pi over 3. So negative tells us we're going this way. Now the 7 pi over 3 brings us all the way back to here, because that would be negative 6 pi over 3 back to the starting point, and then just another negative pi over 3. So we've got a reference angle of pi over 3. Remember, the negative only tells us which way we're going around. And we've got cosecant. Okay, so it's coterminal with negative pi over 3. Okay, and that's negative 1/2, because cosecant, remember, is the reciprocal function of sine, and sine is negative in the fourth quadrant. So it'd be negative 1/2. Okay, so you are going to need to know the fundamental trig identities. So make sure you know the reciprocal identities. 1 over sine for cosecant, for secant 1 over cosine, for cotangent 1 over tangent, or, okay, so make sure you know that this is the same thing, cosine over sine, depending on the information you have. And tangent is sine over cosine, of course. And also the Pythagorean identities. Yes, these are rearing their ugly head again, so make sure you know them. So sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. How are those going to come into play here? All right, so we need to find the values of the remaining trig functions from the information given. So we've got tangent. We need to find all the other 5. So we're given that tangent of theta is negative 3/4. So it's negative 3/4. So negative for tangent tells us it's either here, because tangent's negative here, so it could be here or it could be here. We're also given that the cosine of theta is greater than 0, which tells us that it has to be in the 4th quadrant. Okay? So cotangent's easy enough. Just flip it. So negative 4/3. So that's easy. Now, as far as finding the rest of it out, secant we know is just tangent squared plus 1. So we can take tangent of negative 3/4 and square it and add 1, and that'll give us 5/4, because we can say that is 9/16. If we want to add that, that's going to be 16/16, which would give us 25/16. And because this is secant squared, to get that, we would square root both sides, or the top and the bottom, and get 5/4. Which then we can use, because secant, remember, is the reciprocal function of cosine. So now we know secant, and cosine, all we have to do is flip it. So now all we have left to find is sine and cosecant. So because we know cosine, we can say that the sine squared, or to find the sine of theta, we just take sine squared plus cosine squared equals 1. Which we know sine squared plus, we don't know that, we're trying to find that, but we do know cosine. So 4/5 squared equals 1, which would give us 16/25. So sine squared plus that equals 1. Subtract 16/25 from both sides, and you would get 9/25, which when you find the square root of that, gives you negative 3/5. Why is it negative? Because none of this was negative. Again, we're in quadrant 4. Sine is negative here. Cosine and secant were positive because we're in quadrant 4, but sine is negative. So you need to keep going back to this, to the fact that we're in quadrant 4. Be aware of that when you're thinking about your signs. And then that covers all 5. 1, 2, 3, 4. Oh, we're missing one. Cosecant, which is just a reciprocal function of sine. So just flip the numerator and the denominator and you are good. All right, third example. Let's look at some application problems, and this will be the last one. So a rocket fired straight up is tracked by an observer on the ground 1 mile away. So here's your little observer over here. Rocket's 1 mile away. Let's just say it's 1 mile, obviously not to scale. And our rocket is fired straight up. All right, so we've got this triangle created here, and theta. We need to show that when the angle of elevation is theta, the height of the rocket in feet is h equals 5280 times the tangent of theta. Well, we know that 1 mile equals 5280, so that's how we got that. And to show it, all we have to say is, well, as long as you can show this, that that's the same, so make sure you do show that. And say, well, I need to find the height, which is my opposite of theta. So to do that, because I have my adjacent, so that's going to be tangent of theta equals my height, which we're calling h. So opposite over adjacent, which is 5280. Which would then give us, to solve for h, so we'd have to multiply both sides by 5280. And we'd be good. So all those steps basically show that you don't necessarily have to draw a diagram, but you definitely want to, not like this at least, but you definitely kind of want to draw a triangle that shows theta, shows this as 5280, and shows that as h. Now to complete the table, all we have to do is plug in the degree measure for theta and solve. So in your calculators, you type 5280 tangent 20 degrees. You get about 1922, and then do 40, and you get about 9145, and then 60, and you get about 29,944, and finally 80 degrees would give you about 60,351. So as long as your calculator is in radians, this stuff is fairly easy, because once you start using the calculator, the whole thing becomes a lot easier. So get some practice in that. We'll definitely be doing some practice problems from the book on Monday, next time I see you. But if you ever need more, just let me know and I can assign some more problems if you want some additional practice. Have a good one.